You are frequently going to be in the situation where you need to convert units from one type of unit to another. And some of you may have seen this in a past science class, but I want to talk through the general process of how you do this. The basic rule is that you're going to multiply whatever quantity you have by 1. And remember that 1 multiplied by a quantity doesn't change that quantity at all. It's a fundamental mathematical idea. But 1 can also be a ratio of 2 things as long as what's on the top and what's on the bottom is equivalent. So for instance, 1 is equal to 1 meter divided by 100 centimeters. Why? Because these 2 things are equal to one another. What this means is if you take a quantity, for instance, 5 centimeters, and you multiply it by this ratio, you haven't changed the quantity, but now you're able to cancel the units on the top and on the bottom. So in general, the value on the bottom are going to be the units that you have, and the value on the top is going to be the units that you want. Now, because 1 is equal to 2 things that are equivalent, you can in fact just flip this upside down. So instead of 1 meter divided by 100, you could have 100 centimeters divided by 1 meter. So which of these you choose depends on whether you have centimeters and want meters, or you have meters and you want centimeters. So you can use this with really any type of unit conversion, for instance, meters to kilometers, minutes and seconds. One thing to be careful about is anytime that you're working with squared or cubed values, make sure that you actually are squaring or cubing the entire quantity. It is not true that 1 meter equals 100 centimeters cubed. You actually would have to square that 100, and you then have, in fact, 10,000 centimeters cubed is equal to 1 meter cubed. So be careful when you encounter any situations like that. So you're going to be able to find some problem-solving videos that go through some unit conversion, and it's something that comes up a lot in problems. So if you need more help with this, please look for the problem-solving videos and also look for some of the tutorials on mastering physics. I mentioned before that SI units, the fundamental ones, are meters, seconds, and kilograms. We then have these prefixes that we add to the beginning of them in order to communicate the power of 10. Now, some of these you're going to be fairly familiar with, for instance, centimeters and millimeters, or kilometers. Other examples would be kilograms and milligrams. Now, depending on what science classes you've had in the past, you might be familiar with, for instance, micrograms in chemistry, or even nanoseconds, which comes up in physics quite a bit. Now, these are going to be some of the ones that we see the most. While others exist, we are not frequently going to be talking about micro or nano in this class, though it will come up in Physics 203. We're also not usually going to be talking about mega, or either giga or giga, it's pronounced 2 different ways. These you're not going to see very much in this class either. So it's mostly the ones in the middle, and centi really only comes up in centimeters. We usually don't talk about centigrams. Also notice that for seconds, we might talk about milliseconds, microseconds, or nanoseconds, but we usually don't talk about kiloseconds. At that point, we might talk about days or hours. So these prefixes are really helpful to know, especially when you are given a problem that relates to something happening at the astrophysical or the microscopic scale. Those are especially the places where we need to use these prefixes. So now one other thing on conversions is that we're going to be using these SI units largely, which are again going to be centimeters, kilometers, meters per second, meter, kilometers, meters per second. But in general, as a person, if you're someone who's mostly lived in the United States, you're probably not familiar with those. So these conversions are a little bit helpful to get a sense for what exactly each of these means. Again, 1 inch is about 2.5 centimeters. You don't really need to worry about all of the significant figures here. If you're doing a conversion, you might want to use them, but the more important thing is to have a feeling for what it means. So for instance, 1 meter per second is about 2 miles per hour. To really do a calculation out to convert, you would want to use more than that, but to just have a feeling, if I tell you that you're walking 5 meters per second, that's going to be about 10 miles per hour, and you can ask, is that actually a speed you would walk or not? This is really important to have a feeling for some of these, since when you get a result of a problem, you want to ask yourself if the value is reasonable. I try to make sure that all of the information you're given are reasonable values, so your results should be reasonable as well. So if you're calculating the distance between two buildings and you get 500 kilometers, if those buildings are supposed to be on the same campus, there's no way that that works. Now I realize that you might not have a great sense of what a kilometer is, but you could approximate it to be almost half a mile. So you would expect that the distance between two buildings on the same campus is maybe 1 kilometer, maybe a little more, but probably even less, depending on whether it's a campus like Agnes or a campus like Georgia Tech.